So I'd like to introduce Josh Fraser, who's from a state government agency. It really sounds very nefarious when you say it like that. So he's been working in large government organisations in incident response. He spends most of his time detecting and responding to threats and building out additional capabilities for his team. So if we could have a very warm welcome to Josh.
Hey everyone, welcome to my talk on EDR and EDR solutions. Basically the main premise of this talk is to, I suppose, understand EDR solutions a bit better, but in context of that, trying to look at what tools you have available in your environments and leveraging them to build out EDR capabilities for free. So let's jump into it. So just a quick disclaimer, this conference talk represents my own opinions, not that of the organisation I'm employed by. I think that basically means I can just say what I want without repercussions, so it's good to have that in there. So who am I? Already touched on that, work in a large government agency, pretty much just a random guy that likes detecting and responding cyber threats, and building out additional capabilities for the team in a more incident response perspective, so on the blue side of things. So what's the problem? Why am I doing this talk? And you'll probably notice this isn't a new problem. This has been something that's been an issue for 15, 20 years, is that signature-based technologies and detections, kind of suck. They're very limited in their capabilities. They're very limited in what they can detect. And they're really kind of relying on that whole wall approach of blocking stuff before it can get into the organisation. Just as the keynote presenter reminded us, we can't rely on those big perimeter walls, those big defences. We need to kind of assume that people are already in the network and have visibility of what's going on. And it's really frustrating having to rely on an alert that says something's bad, but luckily your AV has cleaned it up. You don't really know what's taken place. And so without that visibility of what's actually taken place from that alert, it might just be easier to re-image. You might have more assurance just to re-image a box once it's been infected. As you've been walking around, if you're one of the people that maybe have a more traditional AV solution, maybe this is you. You've been walking around, you've seen a lot of really new, interesting solutions that are going to solve all your problems, and you're probably checking them out. And that's good. There are a lot of really cool technologies out there that have really powerful capabilities. But on that side of things, sometimes vendors overestimate their capabilities in detecting and responding to threats. This is obviously exaggerated. This is not a literal thing, just clarifying that. But it's kind of just it's to highlight how important independent testing is when you're looking at these solutions. So there's a group called MITRE in the United States, and they do independent evaluations of EDR solutions. So if you're in the space for looking at buying one, that's something I'd definitely recommend checking out. They do some really good reports. And the way they do their testing is they look at a particular threat actor or an APT, and then they'll test those tools against the different TTPs that threat actor uses, instead of just throwing 1,000 malware samples at it and then seeing that it blocks 99%, which doesn't really show anything. And so what we're going to talk about in this talk, funnily enough, is how we can, I suppose, leverage existing tools in the environment to build out additional capability in terms of detecting and responding to threats. And it's something that really is essential for all organisations of all sizes, of all industries. It's not just something the banks need to do. It's not just something governments need to do. Regardless of your size, it's something you need to be looking at. So what is EDR? I've said that acronym heaps, but I haven't said what it means. And is it different? Is it different to your typical AV vendors or your NG-AV vendors? So we'll rely on Google for the definition. So this is just the first thing popped up, and this is the definition I'll be working off because Google is very reliable. So EDR stands for Endpoint Detection and Response. Endpoint Detection Response solutions are designed to continuously monitor and respond to internet threats or cyber threats, if you prefer that buzzword. So it breaks it up into two components, as with the acronym. You've got on one side, you've got the detection capabilities, and the way this definition puts it is that continuous monitoring on the detection sides, but then you've got the response side. So not only are you able to detect these advanced threats, you're able then to respond to them. And again, being able to respond to an advanced threat is not re-imaging it. It's not unplugging a blue cable. It's using precision to understand what the actor has done and then being able to clean up those things. And EDR is different because it takes a different approach. It takes that assumed breach mentality. So the EDR solution, it's not there to block all the things that are coming in and assume that it can stop them all. It takes a different approach in that it assumes that the host has maybe already been compromised or that it may be compromised in the future. So what it does is it will collect all that kind of endpoint telemetry, and then using that, you'll be able to understand what has taken place if there is a breach that is identified. So how can we use existing tools or free tools to build out this capability instead of giving a vendor quite a substantial amount of money? So we'll focus on the detection capabilities and then we'll go into the response capabilities. On the detection side, it's something that's probably not very new. This has kind of been covered quite a lot in security conferences over the past few years, and it's the Sysmon tool from the Sysinternal suite. And it's a tool that a guy called Mark Razinovich wrote a few years ago, and it's just a very small Windows binary that monitors activities on Windows operating systems. And you're able to define the actual activities that it will log. So it could be something like process creation or drivers being loaded. We're going to look at how we can use then the Windows event log, and then we're going to use Splunk as well. Splunk's obviously not free. In the organisation I work for, that was a tool that was available, but you can follow this same guide and just use like an elk stack or something like that. You can, do the same thing with elk. This is kind of just a slide, just shamelessly stole off presentation Mark did at RSA, and it breaks down the different things that Sysmon is capable of detecting on a Windows endpoint. So you can see there, your process creation, file creations, network connections, a whole bunch of different things there. That's a really good presentation as well, so if you're interested in looking at this a bit further, check that one out. So MITRE ATT&CK framework is been a very popular thing, I suppose, over the past year. And a lot of industries, a lot of organisations are trying to align themselves to it in terms of being able to detect what threat actors are doing. And basically it's just a really helpful framework of mapping out the different kind of TTPs that you're seeing when you're understanding a particular incident or a particular threat actor in your environment. And so someone's actually mapped out Sysmon's detection capabilities to the ATT&CK MITRE framework. And this is a common one you'll see that vendors will also do the same thing, is they'll map out their capabilities. And it's a way that you can kind of compare. It's not the best way of doing it because each of those little boxes is quite general and there's multiple different ways that you can detect those things. So you can bypass it even if it comes up on here. But nonetheless, this is a free tool that someone's mapped out, a really helpful config that maps to the ATT&CK MITRE framework. And what that basically looks like is there's just an XML config that loads into that Sysmon binary. And if we just look at the first line there where it says image condition, you can see the name there, which is the technique that's from the ATT&CK MITRE. And you can see what it's looking for. So it's looking for when WScript is being spawned, process create. So we can see that that's what we want to be logging, and that could be something that's interesting. So that's collecting a whole bunch of kind of rich telemetry from Windows endpoints, but that's stored locally. So it's essentially like a local cache in your Windows event log. which is not really that great. You want to be able to collect all that endpoint data from all your workstations, all your servers. You want to feed it into one location, because that's when you start to do things like big data and analytics and data lakes and buzzwords across that information. And you can do some really interesting thing when you're pulling in all that information. One of the ways you can do that is you can use a Windows service called Windows Event Forwarding. And basically it's just a native service that's built into Windows that allows you to forward logs from your Windows event log to a Windows event collector, which can just be any server that you want. And it's quite simple to set up. If you've got an AD infrastructure kind of setup, it's really easy to get going and to start passing logs. It's just a matter of setting up some GPO. And then what we're going to have is on that event collector server that's kind of collecting all those logs, we'll have Splunk on there. And then Splunk will be able to ingest all the logs from the event collector. So we're now collecting all those Sysmon logs, we're storing them in Splunk, so now we can query those logs as much as we want and run real-time searches and get real-time alerting. So the first search we have on the top there is using a DMA from Splunk, because when you're ingesting lots of data, it can be helpful to use the accelerated data models because it will make it go way quicker and you can run your searches more often. And basically what you can see there is, so your process.process equals star PowerShell, and it's looking for when the command line contains a -e, -enc. So basically it's looking for when your users are using encoded PowerShell commands. This can obviously bring up quite a lot of false positives if you're in a large organization and you've got a lot of admins that like using PowerShell. So below that we've got a bit of a lookup table where we can manage those exclusions out. If you're not managing exclusions when you're using something like Sysmon, it's going to be, alert city. So you've got to manage those false positives as well. Below that we've got an alert for where processes are interacting with Sysmon. So this is kind of a typical thing security tools will do on endpoints, is they want to actually monitor their own stuff. So if you see an attacker interacting with Sysmon or trying to dump the config that Sysmon has, you'll be able to alert on that as well. And then the one below that is kind of a very typical one you'll see for spear phishing. So it's just looking for macroed Office documents. So where you have WinWord, Excel, PowerPoint spawning CMD or PowerShell, it's going to create an alert for that. Again, this is something that can create false positives. I've seen a lot of really interesting things people are doing with Excel and macros, and some really funky stuff where they're pinging servers and pulling down data from servers within an Excel spreadsheet. So you've got to look out for that stuff and manage those exclusions as well. And this is just looking at the process create event. So this is one of those 18 different things that Sysmon logs. So there's a whole bunch of stuff that you can be detecting with this. This is quite an interesting one we were doing, which actually kind of pushes into the realms of your traditional AV stuff. And basically what this is doing is it's looking at all the processes that are running and are being detected by Sysmon and being passed up to Splunk. And then it's actually going out to VirusTotal and checking those hashes of the processes. And this is interesting for a few reasons, because your traditional AV approach is scan everything on the hard drive, whereas this is only looking at stuff that's actually running on the endpoint. So this will create essentially a big database of all the software that's running on your computer, and it's going to then be checking that against VirusTotal. So instead of getting one AV vendor to check it, you're actually getting 70. And so what that looks like is a dashboard that can be kind of pretty. It's got dark theme, which makes it even cooler. But you'll see at the table at the bottom, we've got some detections from VirusTotal. And these particular files don't actually have the company description or file versions filled in, which they're just question marks. So they could be interesting to look at. You'll also see fields like what you can do is you can look at rare companies and rare products that Sysmon is detecting. So if you've got a lot of developers in your organisation, they can often put in strange fields for these when they're compiling their binaries. But it can also be something interesting to look at as well, that viruses can often have different things. Another thing that's interesting with this is where there's a file that's not in VirusTotal, that can also be a good thing to have a look at, because if it's not in VirusTotal, it might be a non-standard file that someone's compiled, or it could be malware as well. Yeah, the amount of things that you can do with this data that's being collected is huge. One of the things that I want to do in the coming months is look at how we can leverage the Sysmon data to do vulnerability management. Because one of the things this actually captures is it captures the file versions of binaries. So if you have, there's a vulnerability in a particular program like Adobe, you can see Adobe running with a specific file version, and then you're able to cross-reference that with a database, and you could see that it's potentially vulnerable. So there's a lot of really interesting things you can do with this. Another thing you can do is do some kind of process trees. My HTML and JavaScript's pretty sketchy, so it's not the prettiest interface. But basically what you can see there is you can see a WinWord at the top, opening a macro doc, spawning PowerShell, you get to see the command line parameters, and then you get to see the persistence mechanisms being put in place and the different commands that an attacker is using. So this can be helpful to kind of visually see what's going on when you're investigating certain things instead of just seeing text. So that can be a good one to look at, and that was all I did for that was just found like an app on Splunkbase and just modified it a bit to do what I wanted. And like you'll notice a lot of these things, I've kind of just copied lots of things off Splunkbase or from other people and then just modified them slightly to do what I want. And that's kind of the premise of this, is a lot of these kind of different things is you can just spend a bit of time and look at building it yourself. So that's on the detection side of things. So with Sysmon, we're able to pull that rich stuff from endpoints. We're able to run those analytics on it from Splunk. And we're able to visualize and do different things once it's in there. So what about the response capabilities? So there's a few different free options. There's not much. So GER is a common one. This is a tool that Google developed a number of years ago. It's got some really good features. However, it can be a bit of a high maintenance one. So there is that. Incident responders often use PowerShell, PSExec. If you're real lazy, again, you might just set up an automatic rebuild from SCCM so you can trigger that at will on endpoints that are infected. But what do we want to do? We want to be able to take a dump. Taking a dump shouldn't be difficult, but it often is for incident responders. How many people here could probably say that they can remotely take a memory dump of any endpoint in their organisation? It's often a difficult thing. It's often a hard thing, but it shouldn't necessarily be. And with some vendors, with some EDR vendors who are in the cloud, there's significant issues with trying to do things like this as well. But you want to be able to do things like remotely contain endpoints, kill processes, copy files, and run custom tools and scripts. If you do use PowerShell and PSExec and RDP for responding to incidents, there's a few things I suppose to be cautious of when you're doing that is you may be introducing privileged credentials onto endpoints that are potentially compromised. So this is a table that SANS put up in one of their courses, and it's a really helpful visualization of when you might be storing your credentials on endpoints. So if you're using RDP and there's no credential guard, that's quite trivial for attackers to then pull your credentials. Even if you are using PowerShell remoting, just be cautious that you're creating a user profile when you do remote in, even if the credentials are not necessarily accessible. And that may be something that could alert someone to your presence in terms of investigating that system. So that's something to be aware of as well. So what are we going to use? We're going to leverage a system process that is deployed on most of the endpoints in the organisation, using McAfee agent. So McAfee agent's not actually the AV component, it's just the agent bit which manages the installs of different McAfee products. It's a really reliable, really quick tool that they've set up. And what we're going to do is we're going to use a package deployer tool that some guy developed that allows us to put custom applications into our EPO and then deploy them via an API to endpoints in our organisation. And the other thing to note, again, if you've got Splunk and you've got Splunk universal forwarders everywhere, you can do exactly the same thing in there. And a lot of other big AV players will have a similar tool built into their agents, so you can deploy custom apps as well. But in this case, we're just going to use McAfee. So we've got a really beautiful interface here for the EEDK tool. And this tool allows us to package up folders or files that we want to deploy onto endpoints in the organisation when we require them to run certain tasks we're interested in. So in this case, what we're going to do is we're going to package up a tool called AutoRuns, which is from the sysinternal suite. It's a tool that will look for common persistence mechanisms for processes on Windows. And then what we're going to do is we're somehow going to get that back into Splunk. So the EEDK tool, you have to point it at a particular file to run. Unfortunately, you can only run CMD files or exes. So that can be a bit frustrating. So we've basically just got, this is the CMD file here, and it's pretty much just pointing to a PowerShell file. There's a whole bunch of logging code in there, which is kind of irrelevant, but it's just calling a PowerShell file. This is the PowerShell file. Again, this is just something I took off the internet. It's just like a syslog script, so you can use PowerShell to set up syslog. And so what we're going to be doing is we're going to be running the AutoRuns binary, which is just in line 15. We're going to output it to a CSV. And then what we're going to do is we're going to stream those results to our Splunk server. And then we're going to be able to see those results being streamed into Splunk. And the thing with this is, once you've done this once, you can pretty much just deploy any IR tool that you fancy. Any free tool that you find, you can package it up. If you can output it to a CSV, you can throw it in this script, and you can actually just be streaming logs straight into Splunk, which is pretty cool. So what that looks like in EPO is you set it up in EPO, upload it, you set up a client task, which allows you to then use the API to deploy the application that you've packaged. This is on the Splunk side of things. Not sure how easy that's going to be to read, but yeah, it's just some Python stuff to actually hit that API, and you can trigger that from a search. What that looks like in Splunk is just a kind of a simple interface where you type in the host name of the device, and you select a particular tool that you want to run. So this is just a subset of tools that we've done, but it gives you an idea of some of the kind of capabilities you can package up into this tool and deploy. This is it running on the actual endpoint. So this is just the McAfee agent log, so you can see how it's kind of downloading the files and then executing them. And then this is the results that are being streamed into Splunk. So you've got kind of just a message status at the top. You've got that middle panel there, which is looking for suspicious outputs of the results. So you can see there that there's some sketchy VDS that's going to be running when that particular user logs on. So that can be quite interesting to look at. This is a POC I kind of did. Yeah, we don't use this in our environment. But basically, one of the things that I kind of see flaunted a bit with the EDR solutions is the ability to essentially just get reverse shells on your endpoints in a secure fashion and be able to respond to the advanced threats in that way. So basically, I just did the same thing. So I packaged up a reverse shell into EPO, I then did some stuff on the Splunk server so it could accept the connections, and then I've passed it through to the Splunk GUI. So you've kind of got a nice HTML interface for managing endpoints and cleaning up endpoints. And again, this was just an app that I took off Splunk base and just modified a bit to get it to do what I want. So let's crack into a demo. It's probably a bit of an unnecessarily complicated demo. We got 4 VMs, so we're going to load those up and try. And the reason why I did it this way is because I wanted to make it a bit more realistic for what this kind of architecture looks like in environments, as opposed to just doing it on a single VM. So basically what we've got here is we've got 4 VMs. We've got a Kali, which is just going to be your attacker. We've got a McAfee EPO, which is a 2016 server. CentOS, which is just your Splunk box. And then we've just got a standard workstation. So we'll just have to wait for all those to load up, which should just take a second. So we've got our Kali box here. It's just going to be a typical kind of spear phishing scenario. So we've just got a basic listener here, kind of ready to go. So let's just get that listening. And we'll just wait for the Win10 workstation to spin up. But yeah, we're just going to go through spear phishing. So there's just going to be an email that a user's received. That's going to be a very sophisticated phishing email. So the user's going to see this and they're automatically going to want to open that invoice and check what's inside. So let's just go through this and we'll see if stuff works. So yep, it's just kind of a typical one. I'll just go through and ignore that. So yep, the user's seen nothing. They probably don't think much of it and probably just close it off and ignore it. But if we jump back to our interpreter thing, we've got a full session now. And so one of the things the attacker might want to do is set up some persistence. So we can just use some scripts in interpreter that make this really easy. And basically what it's doing here is you can see that it's using C scripts to execute a VBS, but it's also creating a key and registry that's going to execute when the user logs on. So maybe now they want to run some commands, maybe see what user context they're under, or I don't know, what their IP address is or something. So you can just do all the normal kind of things in there. So if we now go into Splunk, we'll have a look. And so we'll just go into custom EDR app. This is a free version of Splunk, so we can't do alerting. So I've just created a dashboard, but essentially you just have an alert that runs every 5 minutes or something like that. What we can see here is we can see firstly that technique that's being from the attack MITRE framework, so you get to see that. You get to see WinWord spawning PowerShell.exe, and then you get to see the command line parameters that are being used. And I made this intentionally pretty easy to see. I didn't encode it or anything like that, just so you can see what's happening. But yeah, it's pulling down boring.html, saving it as payload.exe, and then proceeding to run payload.exe. So from here, we'd have a Splunk alert, something that we can act on, but it's an alert, it's a point in time. And yeah, if it was AV, the AV might have blocked part of it, and you get a block message, and that's about it. So if we look at, say, process persistence, we can see, yeah, kind of what I showed before on the slides. But yeah, the payload.exe 2 minutes ago wrote a key and registry, and it's just pointing to a VBS file. So when that computer logs on as that user, that persistence is going to be triggered. So what we can do then is we can kind of visualize what's just taken place. So we get a bit of a process tree of the commands that have been run. So we can see from the top here, WinWord running the macro doc, PowerShell code. We can see on this side of things the persistence that's being set up and running the executable. And as what we'd start to do is, and incident responders, we're probably wanting to start to take some notes of what's happened on the endpoint, so we know what we need to go through and clean up. So we can see here we definitely want to kill this process, and we'll want to delete that file, so let's make note of that. And you get to see some of the other stuff that's been going on as well. So we're probably going to want to clean up that registry key. You can also see those network connections. I think the ports as well. So the file was pulled down on port 80 and the reverse shell is on 443. We'll get though to that. And then there's that VBS file we also want to clean up. So we've got a bit of an understanding of what's taken place on the endpoint. We can see quite reasonably that it's what's taken place. We can also see the commands that have been entered. And the interesting thing with this is when you start to see where there's like 4-second gaps, 3-second gaps, or random gaps between the commands, that may indicate that there's someone on a keyboard as opposed to a script. So that can be something interesting to do. So we're going to also want to kill C script, because that's currently running that VBS file you can see here. Cool. So instead of going into response straight away, what we're going to do is we're going to deploy that auto runs tool just to show you how that works. I've just got to copy the name of the computer first. To show you what that kind of actually looks like. So if we go down onto the McAfee agent here, it's starting to pull down a package so that it triggers it within like 15-30 seconds or something. It's crazy quick. It's going to pull down that and then that's going to run. So to show you what that looks like, let's go on Task Manager. We can see the auto runs process here has been triggered. That's the command line. That's where it's running from. So that's how McAfee's deploying it and running it. And then what it's going to do is it's going to stream those results to Splunk. So we can see PowerShell here is the one that's running it. So if we jump back to Splunk, we can see that a message has been sent saying that it started to run, that it's running, and that there's some results coming back. So if we just refresh this dashboard, we're going to start to see some interesting things that auto runs has been pulling. So right up the top here, you get to see the most interesting one, which was from how we set up persistence. So it happened 6 minutes ago. And what we could do here is we could then check that what Sysmon has captured is the same as what auto runs is capturing. And you'll see that those files match up. You can also use this just to run randomly on endpoints and collect data into Splunk and then take response based on that. So there can be some interesting things that auto runs do. But again, you can just pack up whatever tools you want or whatever you use in IR and stream those results into Splunk. So we've got that information. We feel comfortable, we know what's taken place on the endpoint. The attacker still has their session. So what we're going to want to do is we want to go and clean that up now. So let's use the reverse shell. We're going to deploy it to the desktop, the workstation that we're on. We're going to see that McAfee is going to proceed to deploy that. If it works, or we're waiting, we can have a look at some banners that I've put in there. You need some ASCII art. If any cybersecurity tools, if they don't have ASCII art, are not real tools, so you've got to include that in there. So that tool has now been deployed and is running. So we could do all the typical things that you could do from like a command prompt window. So you could run task lists. You could see all the processes that are running, so like payload and C scripts. And so what we'll do is we'll put that side by side with the actual OS. So we can see the payload there, it's come up here. It's the same PID, it's the same thing. Maybe what we want to do as well is we want to look at, oh, you're not typing. Maybe we want to look at the processes that are having network connections, so you could do all the same stuff through there that you would. The cool thing about this though is this is running as a system process. So you're not using any credentials, you don't have to have a domain admin account, a very privileged account. It's running as system, which is kind of cool. And you could obviously hide this instead of just having the standard default Python icon and make it a bit inconspicuous instead of legit reverse shell. But that kind of shows you what that looks like. So we've got that information. So what we want to do is we want to start cleaning this endpoint up. So let's start off, let's kill that session. So we're going to do that by just killing payload.exe, and then we're going to kill C scripts. So if we jump back to interpreter here, session's been killed, they've been kicked out. So we killed the C script, which is what was running this persistence script here. So that was the thing that was going to make it call home every 500 seconds. So the only other thing then we need to do is we need to kill this one off so that when the user logs off and on again, it doesn't run that VBS file. So what we'll do is I'll show you Explorer. So we can see the payload file there, so we're just going to kill it, delete that. And then we're going to go through and get rid of that VBS file as well. Should have given it a shorter name. I'll see if that works. And I've spelt it wrong. It doesn't matter, you get the point. And then what you'd do is you'd be able to then remove the registry key as well. So in a similar fashion, you can just run standard command prompt lines to clear those things out. So if we go into here, you can have those commands saved in and then just go through and clean up. So if we go, oh, that's another long one as well. I'm not going to type that in. Anyway, so you could go through then and clean that up as well. And then by the end of that, essentially, you can feel comfortable that you've cleaned up all the stuff on that endpoint. You've remotely responded to it. You haven't had to call a user. You haven't had to re-image. You're all done and dusted. And the cool thing with this is it gives you that assurance that you've actually cleaned up the endpoint instead of just seeing a blocked message. And this is all, this is all free. Like, you can just go build it yourself, and we can just then kill that session off, and then you're back to normal. One of the other things you can do is, I don't know if we'll have time to demo it, but you can do memory dumps, and the way that that works is you're again just deploying a script that runs, but because a memory dump can be quite huge, you just set up like an SFTP server somewhere, or on your Splunk box, or on your EPO server, and then in that script you define the server to connect it to. But I don't think we'll have time for that. 6 minutes, we'll just finish it. Here's some references, just some of the stuff that I've been reading through as I've been working on this. So there's some really good links, particularly on the Sysmon side of things from BotConf. There's a guy there who's done some really high quality talks, so check him out. But yeah, that brings us to an end of the talk. And yeah, I suppose just one quick thing is, don't hear me saying you shouldn't buy an EDR solution. That is not at all what I'm saying. In the vast majority of cases, there is some, it is worthwhile to seriously consider looking at that tech, because it does provide something that other solutions don't. But yeah, evaluate what they actually provide to your incident response team, and make a good business decision, I suppose. But yeah, that brings us to an end. Thanks, guys.
Thank you. That was a fantastic talk, Josh. Thank you very much for that. Are there any questions from the audience? We have about 5 minutes, so we've got plenty of time for questions if there are any. Oh, there you go. Get my steps up.
Thanks, Josh. Just a few thoughts, if you wouldn't mind, on this approach when you've got maybe a slightly less one-way, same-way fleet, i.e. you might have a mix of Mac or something, as well as comparing some open source EDRs like Wazoo and things like that. Just some thoughts on that, please.
Yeah, so I suppose the experience I've had is in relation to the organisation I work at, and so Windows is 99% of what we have. So I haven't spent time looking at how you could do it in Mac. But I suppose in some regards, yeah, if there's ways that you can centralise security logs and events that are being generated on endpoints and pull it into something like a scene, you have that ability of being able to do some interesting things when you're starting to pull in lots of data. But yeah, so I probably can't help much on the Mac side of things.
Awesome. Are there any other questions from the audience? I have one. What's your browser history look like now after you had that dump slide up?
What's that?
You know, you had that cartoon with the guy taken on the toilet. Love to see your browser history now. Alrighty, thank you very much, mate.